geometric series, recurring decimals. Recurring decimals can be expressed as a sum to infinity of a geometric sequence where the common ratio or is less than 1. So for example, 0.3 with a little dot means 0.3 recurring, which is equal to 0.33333333 dot 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 on and on forever, which can be broken down as 3/10 plus 3 over 10 squared plus 3 over 10 cubed plus 3 over 10 to the power of 4 plus dot 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 on and on forever. So what's happening is you started off with 3/10, so 0.3, and you multiplied by a tenth to get 3 over 10 squared, and you multiplied by another tenth to get 3 over 10 cubed, and you multiplied by another tenth to get 3 over 10 to the power of 4, and so on. And all of those added together will give us 0.3 recurring. So it's like breaking it down into fractions, where the A is 0.3, so 3/10 or 0.3 means the same thing, and the or, the common ratio that you're multiplying by each time, is a tenth. So 0.3 recurring can be broken down into the sum of these fractions. Similarly, we can take 0.235 recurring. So notice that the dots are above the 3 and the 5 only. They're not above the 2. So this can be written out as 0.23535353535 dot 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 on and on forever. So if we want to break this decimal down into a sum of fractions, we start off with 0.2, and then we add on 0.035. So that will represent the first 35 digits. And then we add on 0.00035. So that represents the second set of 35 digits. And then we would be adding on 0.0000035, which would represent the third set of the 35 digits, and so on. 0.035 can be rewritten as 3 over 1,000. And 0.00035 can be rewritten as 3 over 100,000, and so on. So what's happening each time is you're multiplying by 1 over 100. So 0.035 multiplied by 1 over 100 is 0.00035, and likewise 35 over 1,000 multiplied by 1 over 100 is 35 over 100,000, and so on. So each time you're multiplying by 1 over 100. So this is all equal to 0.2, so that's what we started off with because the 2 has no dot, so 0.2 on its own, plus an infinite geometric series, where A is equal to 35 over 1,000, so the first term of the geometric series is 35 over 1,000, so it's not 0.2 because that's not actually part of the geometric series, okay, only any of these values are, so the 35 over 1,000, 35 over 100,000, and so on, that's part of the actual series. The 0.2 is just at the start. And or is the common ratio. We're multiplying by 1 over 100 each time. So there's just a couple of examples of some recurring decimals broken down into fraction parts. So example 4. Write the recurring decimal 0.23 as a fraction in the form of A over B, where A and B are elements of the natural number set. So A and B are positive whole numbers. So 0.23 with dots above the 2 and the 3 can be rewritten as 0.23, 23, 23, dot 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 on and on forever. So we can break it up into separate parts. So I'm going to do it with decimals here. So we start off with 0.23. Then we add on 0.0023. Then we add on 0.000023. And then if we wanted to go again, we'd add on 0.00000023 and so on. So we're just breaking this up into separate parts. Now 0.23 is the same thing as 23 over 100. 0.0023 is the same thing as 23 over 10,000. And 0.000023 is the same thing as 23 over 100,000, and so on. So A is 23 over 100, so that's our first term. And the ratio is term 2 divided by term 1, which is going to be 23 over 10,000 divided by 23 over 100, which gives us 1 over 100. So what's happening each time is we're multiplying by 1 over 100. So the limit of Sn as n approaches infinity is equal to a over 1 minus r. So this is from our formula book. So no need to learn it off. So a is 23 over 100. So we replace the a, our numerator, with 23 over 100. And the r we know is 1 over 100. So we replace the r with 1 over 100. And we end up getting 23 over 100 divided by 99 over 100. So 1 minus 1 over 100 is 99 over 100, which gives us 23 over 99. Note that the limit of Sn as n approaches infinity is often written as S infinity. Thus, S infinity is equal to 23 over 99. So the recurring decimal, 0.23, as a fraction can be written in the form of a over b, where a and b are elements of the natural number set. The a is 23 and the b is 99. So 0.23 recurring rounds off to 23 over 99. So it gets closer and closer and closer to 23 over 99. So if we want to solve the same question algebraically, if we let x equal to 0.232323 ... then 100x is going to be 23.232323 ... So we're multiplying by 100 because there's 2 decimal places repeating itself. So if there was 3 decimal places repeating itself, we'd multiply by 1,000. So it depends on how many decimal places are repeating itself to decide what number you multiply by. So if we let the top line be a and the bottom line be b, now we're going to subtract a from b. So 100x minus 1x is 99x. And 23.232323 minus 0.232323 and so on leaves us with 23. So that's because 100x minus 1x is 99x, and 23.232323 minus 0.232323 leaves you with 23. So that's where that's coming from. And then we just solve for x. So x is equal to 23 over 99.